Okay, hello everyone. So we're going to go into a new chapter, chapter 6, chemical equilibria. So chemical basically comes from the word chemical reaction, so your chemical reaction, and equilibria maksudnya to be in a state of equilibrium. So state of equilibrium tu macam mana? It's like it's balance, okay? Balance, sama basically, equal, okay? Stuff like that. So, the first subtopic is 6.1 and you have two other subtopics, 6.2. 6.2 is equilibrium constants. Yang tu panjang sikit. Okay. So, let's go into the first subtopic. What you're going to learn today, you will learn how to explain the following terms. You have reversible reaction, dynamic equilibrium, and law of mass action. And then you're going to state the characteristics of a system in equilibrium, basically the characteristics of a dynamic equilibrium. And then finally, you're going to interpret the curve of concentration of your reactants and products against time for a reversible reaction. Okay, so maksudnya ni awak akan learn how to draw or sketch a graph and understand the graph of concentration against time. Right? So, the types of reactions that you have are reversible and non-reversible reaction. So the first one we're going to see is non-reversible reaction. Non-reversible maksudnya you cannot undur, you cannot ghostan. So you cannot reverse, okay? The reaction, it is a reaction that proceeds in only one direction, that is toward the formation of product. So it goes in one direction only. So you have your reactants and you have your product. So your reactant will always be on the left and your product will always be on the right. So you can see that your reactants here, A and B, will form product C and D. So in a non-reversible reaction, your equilibrium is static equilibrium. Static equilibrium maksudnya once the reaction completes, it will stop. Okay, stop reacting. Okay, so for non-reversible reaction, you have this normal arrow yang you usually see. Okay, which means all your reactants will form product. Okay, so macam awak bake a cake, awak guna flour, egg, sugar, vanilla extract, yeast kan. And then when you mix, okay, and then you get the cake, which is the product, then habis dah awak punya reaction. You cannot turn the cake into flour and egg again, betul tak? So maksudnya itu non-reversible reaction, contohnya lah. Okay. So, for reaction that does not go into completion, those are your reversible reaction. Reversible reaction is chemical reaction which take place in both forward and reverse directions. So that means you go forward and you boleh pergi form the products, and from the products you can form balik your reactant. Okay, your reactant can become product, that is the forward reaction, and your product can become reactant again, that is the reverse reaction. So it is indicated by this equilibrium sign. Okay, equilibrium sign. This means that when in equilibrium, your reactants and products, all four of your species will be in the solution. Okay, an equilibrium mixture, this equilibrium mixture contains all four species, A, B, C and D. Okay, yeah. So, basically reversible reaction is that you can go both forward and backward direction, okay? The net concentrations of A, B, C and D do not change. So we'll see that in dynamic equilibrium in the next slide. Right. Your reversible reaction, it can reach a state of equilibrium. So the equilibrium for reversible reaction, the state of equilibrium is dynamic equilibrium. Okay, dynamic equilibrium. So what does dynamic mean? Okay, dynamic means it is constantly changing or constantly progressing. That means the reaction does not stop until it reaches equilibrium. So even when it reaches equilibrium, there is something going on. Okay, right. So how do you know what are the characteristics of a dynamic equilibrium? Your chemical equilibrium is a dynamic equilibrium when the reactant concentration and the product concentration remain unchanged. So that means in the state of balance, in the state of equilibrium, there will be no further change in the amounts of your reactants and products. Okay, that's why nanti awak punya concentration of reactant and product remain unchanged. Okay, remain unchanged maksudnya dia constant, sama je. Bukannya maksudnya reactant tu equal to product ya. Concentration dia bukan equal tapi dia remain the same. Okay, bukan ini. Ini bukan. Another thing, your equilibrium is dynamic when the rate of your forward reaction, so reactant forming product is equal to the rate of reverse reaction. So that means rate of forming the product is equal to the rate of product forming reactant balik. Okay. It makes sense kan bila awak punya rate ni sama dengan ni dan awak punya reactant punya concentration akan remain the same and awak punya product terbalik lah ni. And reactant sama je. Become constant. Okay. Okay. Another thing is the reaction quotient Q will be equal to the equilibrium constant K. Okay. So, reaction quotient Q is your quotient for your reaction at any time. At any time or at that time. Mana-mana time. Okay. So, equilibrium constant K is when your reaction has achieved equilibrium. Is at equilibrium. Okay. So, when your Q is not equal to K, okay, K ni benchmark untuk equilibrium, then that means that your reaction belum capai equilibrium. When your Q is equal to K, that means your reaction is in the state of equilibrium. Maksudnya dia dah capai benchmark dia. Okay, so we'll see later. You have two types of K. You have Kp and you have Kc. We'll see later. How do we understand better? We will sketch a graph. So right now, for this reaction, 1 mole of N2O4 gases will form 2 moles of NO2 gases, and this is a reversible reaction. So you can go forward or you can go backward. So let's see our graph here. Okay. From this graph, first we're going to need to know how does our reaction start. So this is a graph of concentration against time, right? So we're going to see at the start at t equals to 0, okay, initially, what do you have in your system? So the concentration of NO2 at t equals to 0 is 0. So that means you have not formed your NO2 gases. Okay. But the concentration of N2O4 gases is up here. You have a concentration. That means you have N2O4 in your system. Okay. So as your reaction progresses, your N2O4 concentration will decrease. Okay, that means that your N2O4 is being consumed, digunakan. And at the same time, the concentration of NO2 increases. Okay, When it increases, okay, maksudnya dia ada lah. So, you are forming NO2 molecule. So, from this chemical equation, your reaction is starting from it's starting from N2O4. So, it is going forward. Alright? Okay. So, how are you going to explain that this reaction is a dynamic equilibrium? Remember the 3 things that we need to notice. So, first of all, is that your reaction after T1, it does not stop. It is going on. Okay, constantly changing, constantly progressing. Something's going on. Your reaction is still going on. But after T1, you can see that the forward reaction, okay, the forward reaction and the reverse reaction occurs at the same rate. So, rate of forward is equal to the rate of reverse reaction. This happens because the concentration of your reactant, N2O4, remains unchanged, and the concentration of your product is also constant. It remains unchanged. So, that shows that your chemical reaction has reached equilibrium, is in equilibrium after T1. Okay? Maksudnya dia dah aman dah, dia dah settle down. Okay? So, the reaction is still ongoing kan? It does not stop. So, that shows that your the chemical equilibrium is dynamic equilibrium. Okay? Bukan static yang dia stop. It is going on. Another characteristic is that your reaction quotient is equal to the equilibrium constant. Okay? So, 1 cakap pasal quotient dengan equilibrium constant. 2 cakap pasal concentration of your product and reactant. It remains the same. It is constant. Okay? Because why? Because you have reached equilibrium. So, in equilibrium, the rate of your forward and reverse reaction is equal. Boleh? Okay, so tu je. So, tu 3 benda yang awak perlu ingat untuk dynamic equilibrium. Okay, lagi satu. Kenapa awak punya curve untuk NO2 ni lagi tinggi daripada untuk N2O4? Okay, kenapa? So, tengok awak punya chemical equation, you can see that 1 mole of N2O4 forms 2 moles of NO2. So that's why, as you consume 1 mole of N2O4, you will form 2 moles of NO2. So dia 2 kali ganda lah. Okay, dia lagi banyak. Alright? Okay. So ingat after T1 ni, your system is in equilibrium. Okay. Because of the 3 reasons. 1, 2, 3. Okay. Right. Law of mass action or law of chemical equilibrium. Okay. It says that for a reversible reaction at equilibrium and a constant temperature, a certain ratio of reactant and product concentrations has a constant value K. What is K? Your equilibrium constant. So basically, the law of mass action, it relates the concentration of your reactants and products at equilibrium. Right? So, let's consider this general reaction. For that reaction at equilibrium, apa yang dikatakan oleh law of mass action tadi is that the concentration of your products, okay, your products will be concentration of your products raised to the power of the stoichiometry coefficient, okay, your mole, your number of mole, to the concentration of reactants raised to the power of your stoichiometry coefficient juga will have a constant value of K, which is your equilibrium constant. Okay. K ni, your equilibrium constant, is a ratio. So, kalau dia ratio, then it will have no unit. Why? Because your units here has cancelled out each other. So, K will not have a unit, okay? Okay, ini bracket, square bracket ni means that, shows that it is concentration. Okay. This is actually Kc. Kc for concentration. You have Kp as well. So, kalau Kp, cara tulis awak punya expression, okay, this thing is called expression, will be partial pressure of C to the power of C, and then your product, so partial pressure of D to the power of D over partial pressure of A to the power of A kecil ni, your mole, partial pressure of B to power of B. Okay? Okay. So, it says that at a constant temperature, at a certain temperature, asal the temperature is the same, the value of your K will be the same for this reaction, for a certain reaction. If you change the temperature, then the value of K will be different for this reaction. Okay? Okay. Another thing about K is that K tells you how far your reaction has gone. Meaning, how much product you have formed. Because K is proportional to the concentration of your products, right? So, if you form a lot of products, so maksudnya awak punya reaction dah form banyak produk, that means then your K value will be greater. Alright? Okay. Okay. So, like I said, at constant temperature, the value of your K will be the same for this reaction. So, let's see the different cases that we can have at different concentrations, okay? But at same temperature. How do you know? How does the reaction start? So, for case 1 of this reaction, you have this graph. Can you tell how does the reaction start? You're going to look at T equals to 0, right? So, you can see that N2O4, you don't have any N2O4 at the start. That means that you haven't formed any N2O4. And you have NO2 in your system. So, that means in this reaction, you start with NO2. That means it is a reverse reaction gini. Right? Okay, the explanation will be the same as just now. So, you can read that by yourself. So, what I just want to point out is that you can start with different concentrations of your reactants and product, okay? So, second case, at T equals to 0. So, initially, you can see that your NO2 concentration is 0. That means you haven't formed any NO2 gases, but you have N2O4 in your system initially. So, that means your reaction is going forward from N2O4 to 2 moles of NO2. Okay, so the concentration of your reactants and products, they are changing until they reach T1. When they reach equilibrium, the concentration of your reactant and product remains unchanged. Okay, so maksudnya they are in equilibrium dah. Okay. So, case 3 for the same reaction. Okay. Right here at T equals to 0, concentration of NO2, you have a concentration up here. And you also have a concentration for N2O4. So how do you know which of them did you start with? So is it a forward or reverse direction? Okay, how do you know? You're going to see the slope, okay, of concentration. So you can see that NO2 punya slope, dia punya concentration is decreasing. That means NO2 is being consumed, right? And N2O4 is forming. So that means you are starting with, direction is going from NO2 to N2O4. Boleh? Okay. Point lain sama je. Just that I want to show you that you can have different interpretation of the graph for the same reaction. So kalau awak kena looking graph, make sure you know with which substance you're going to start with. Okay. Last pun dia akan reach equilibrium. Okay. In dynamic equilibrium. Okay. Right. So to summarize 6.1, you have learned like just 3 points. So basically the reversible reaction is a chemical reaction which takes place in both forward and reverse directions. So dynamic equilibrium, dynamic maksudnya always reacting. So the condition in which your forward and reverse reactions occurring at equal rate. Okay. So ada 3 karakteristik tu. So remember that. And then you have law of mass action where you relate the concentration of your products and reactants, right? So you're relating these two, and this ratio of the concentration of product to reactant is equal to K at a constant temperature. Okay. Alright, so that's 6.1.